Hello everybody, welcome back to my YouTube channel. I'm very glad to be back, and today I'm going to be talking about something that I definitely saw as worthy of being mentioned on my YouTube channel, because it's honestly one of those things that, yes, it needs attention, yes, and I'm going to do it for you, yes, you are in a safe spot. So let's just get into the video and talk about it. So guys, we talked about, I really don't know like what to call this topic because it's everything, but I am going to be essentially comparing. This is something that comes back in Rosario a lot. So I am going to be comparing translational speed when we're talking about, I suppose, coming down an incline, free falling, well, coming down an incline, but they do not rotate, they only slide. So let's see how that works and let's see what's up. Oh, okay. But first, as you're seeing on the screen, I've talked about free fall first, and I've talked about free fall by comparing it to rolling down an incline. Okay, all right. So let's read this. It says in free fall, final velocity is greater than the translational velocity of an object rolling down an inclined surface from the same height, because all the potential energy becomes translational kinetic energy. Whereas in rolling, some of the energy becomes rotational. So objects in free fall move faster in terms of linear translational speed. Guys, essentially what this means is that this is my translational velocity, translational speed in free fall. Okay? This, let's say, obviously it differs for the shapes, but I'm going to pick, let's say, a ring, okay? And we know that that was that was a very ugly end, but I'm gonna fix it for you. Okay, so V, we know that it's GH. All right. Let's give some numbers, okay? Let's say H is 4. Let's pick 4, okay? So 4 times 9.81 times, we said H is 4, right? So no, we said H is 2. Times that 2, that's 4. So that'd be 6.26. Here, 9.81 times 2, that is 4.42. Guys, try it for any of the other shapes for the sake of this video. I'm going to try, let's do a solid sphere. Alright, so for solid sphere we have 10 over 7 GH. Don't worry, I'm going to teach you how we found this, okay? Don't worry. So that'd be, I told you that the H was going to be 2, so 2 times 10 times 9.81 divided by 7, that's going to be 5.29 meter per second. Still, guys, look, it's still going to be more than both of them. I'm not making that up. You could check for yourself, but make sure to give the same height because we don't want to cheat, you know. But essentially, what you saw was that it was all of it, you know. So they are the transitional speed in free fall is more than that of rolling down. So I wanted to show you guys mathematically, and in case it didn't make sense, but now mathematics is there to prove everything. So guys, now let's talk about the physics part. The reason why this mathematics worked on this question was because I would love to explain this in Kurdish, but let's just stick with English because I want my English community to also benefit from this. But what I'm trying to say is that you're going to compare two cases. In free fall, you have energy only in the form of translational kinetic energy. Guys, let me just talk about something. when you, in free fall, we don't have rotation, okay? We really don't have rotation. So when we do not have rotation, none of our energy is converted to rotational kinetic energy, okay? Hence, my energy is not lost. And all of my energy is just primarily as translational kinetic energy. And obviously, if you have more translational kinetic energy, your translational speed is going to be more. Like, that's common sense, I'm afraid. Okay? So that is the reason. That is why in free fall, physics-wise, that's the reason. I mathematically showed you why in translationals, the translational speed for free fall is going to be more. Okay? And it's going to reach the bottom in less time. Guys, that is very, very important. You have to know that. You have to know that. Do not, for the love of Lord, go into Fizya without not knowing any of that. I repeat, in free fall, the translational speed is more. This V is more where when comparing it to rolling down. And that is because in free fall, none of our potential energy is converted into rotational kinetic energy because we're simply not rotating. Okay? All right? That's it. That's just it. And mathematically, like I said, I showed you can try it for your own. All right. Another very important thing that I was like, I need to talk about this because there's a question. I'm going to read you the question, but let's talk into it, guys. I do not care if you know definition. I do not care if you don't know English very well. I do not care about any of that. But what I do care is that you consider these things as the same thing. When it tells you it's skidding, when it tells you it's sliding, when it tells you it's slipping, you consider them the same thing, okay? All right, I wish somebody told me that in my first year, in the beginning of my second year. None of it. I had to figure that out on my own. But it's amazing. It's an amazing tip. All right. It says with slipping, skidding, sliding, you're going to say it only has translational kinetic energy, no rotational kinetic energy. But without, it has both. Now, this is the question, guys. This is the question. All right. So the question says, a solid spherical shell, oh my God. What was that? Alright, says, a solid spherical shell rolls along a horizontal smooth surface at a constant linear speed with slipping. What is the ratio of the total kinetic energy to the ratio of the translation? Well, it says the ratio of total kinetic energy to translational kinetic energy, guys. I am pretty confident that your teacher has taught you about this. And it's essentially like this. Guys, I will write up and down. When I mean up and down, let me just draw you guys a fraction. This is up. Essentially, I really do not have time to write down numerator, denominator. Just know that up is numerator, down is denominator. All right. We know, I'm sure your teacher told you this, and he told you that, or she told you that, the kinetic energy for rotation is going to be up, all right? It's going to be simply, let me just double confirm that I'm getting it right. Am I getting it right? Of course I am. All right, so he told me, my teacher, he said, well, up, and he said kinetic energy for translational rotation is going to be down. And obviously, when you're saying total kinetic energy, it's going to be up plus down. All right. So this is where that thing comes into play. All right. It says that, let me just go back to the question. It says, with slipping, guys. With slipping. With slipping tells me that there is no slipping. With slipping, it tells me that there is no rotational motion. So, no kinetic rotation. Rotational kinetic energy, right? So this is 0. Okay, so it says what's the ratio of the total kinetic energy? Guys, now the total kinetic energy is going to be purely translational kinetic energy. And it's talking about the ratio of total kinetic energy, which is purely translational energy over translational energy. Can you guess what's the answer? Yeah, It's 1. It is actually just 1. Guys, whatever number you put in, but I'm just going to use up and down, all right? I'm just going to use up and down. This question told me that total no, it actually didn't tell me anything. It just said with slipping. I know that it's with slipping. That means rotational kinetic energy is 0. All right. So that means that the translational kinetic energy, which is actually total, is going to be just purely trans kinetic energy. Now, let's take the ratio, guys. So I'm going to say trans kinetic energy over, again, trans they cancel out. They give us 1. So the answer is 1. I love this question. It was amazing. When my friends posted it, it was amazing. All right, so that I want you to memorize like your own nose. So with skidding, sliding and slipping, rotational kinetic energy is 0. It only has translational kinetic energy. Usually, this question usually typically targets the ratio, between the kinetic energy. Okay, but if it asks you for translational kinetic energy, no problem. Okay, but I don't actually think it will ask you for that. It will simply just focus on the ratio, which is very nice. So if it says without slipping, skidding, sliding, we're going to say has both kinetic energy. That means both rotational and translational. This is the one that comes back. You go and see the questions. It says without slipping. I've seen it like a bunch of times. I just saw it now. Let me see more questions. Hold on. Guys, if you guys go and look at without slipping, that's right. That's what I want you to say. Yeah, that's right. That's exactly right. Okay. I saw like 3 questions like that. I was checking the questions to see. All right, now let's come back to this part, which is amazing. Look, when an object rotates, not rotate. When an object rotates over the inclined surface and comes down. By the way, this terrible English I just copy pasted it from my measurement. That's where the terrible English came from. No, I don't want to sound rude. All right. When an object rotates over the inclined surface and comes down, they do not slip. Each object comes down at its own speed, which we find by this one, guys. So 2 times denominator over numerator plus denominator. Guys, by the way, you will be using the shapes from the moment of inertia. Let's try for a solid sphere. So for a solid sphere, it was 2 divided by 5. So according to this rule, it should be square root. I cannot draw square root, but it's going to be square root of, so 2 times 5, that's 10, divided by, actually let me do GH, and then divided by 2 plus 5, that's 7. Guys, try for the rest. You're going to have the answer, right? Alright, so they have lower translational speed because some of their energy is converted into rotational kinetic energy, and we talked about this. I'm not so interested. So the potential energy is converted to both types of kinetic energy. Alright, guys, how to find the value of total kinetic energy? Now, we talked about the ratio, that's easy, but for value, you're going to say up plus down. Up, like I told you, is the numerator, down denominator. So up plus down 2 times, oh guys, oh, I forgot this. Yeah, pretty sure it's that. So up plus down, and then over 2 times down, mass times velocity squared. Okay, guys, on an inclined surface, neither kinetic energy nor angular momentum is conserved. Where I stopped. So, guys, for this note, it says that when objects come down an inclined surface, they do not rotate, they slide. And all the objects come down together at the same speed. By the way, let me just go back one sec. I told you they do not rotate, and they said they slide. So with sliding, okay, we have zero rotational kinetic energy. So no wonder we're not going to rotate, because not only does it tell me that we're not rotating, that's one hand, and it says they slide, that's another hand, okay? They all tell me that the rotational kinetic energy is zero. So we only have translational kinetic energy. By the way, guys, I think I did say that they won't really ask for the velocity here, but if they did, you know what to do. You know what to use this rule, okay? This is what you're gonna use, nothing else, nothing more. This is what you're gonna use. Honestly, I would be even surprised if they brought a question like this, okay? Because it's not mentioned anywhere, not that I've seen it be mentioned anywhere, where they ask you and they be like, find us the translational kinetic energy, no? Like, if we have all that. If you guys did find it, or if you know someone that made it into a question, I'd appreciate if you guys wrote it in the comment section, because like it'd be good for everyone, right? Okay, so guys, now to this rule. And it says that together they come down at the same speed. I think I've talked about it here, so I don't need to revisit it. But let's talk about this one, I'm interested. It says when objects free fall, they have greater speed and reach the bottom in less time. Guys, it's true, they have greater speed, and I did compare this right, I think it was like maybe 5 minutes or 10 minutes into the video. I mentioned that we compared it. We compared the speeds as to when it's rolling down an incline or free falling. I do not need to repeat myself, but that was it, okay? I believe by the time you reach this part of the video, you should be acquainted with all of this, okay? All right, and it says they reach the bottom in less time. This is the fun part. Why do you think in free fall they reach the bottom in less time? All right, it'd be fun, and I am sure that you think of it. It's because, guys, when you're free falling, all the gravitational potential energy is converted to kinetic energy, translational kinetic energy, and not to rotational kinetic energy. But if we were rolling down an incline, the gravitational potential energy is converted to both rotational and translational. So it's rather distributed. So you will not have the speed that will that will be like you won't have a high I suppose this speed as if we were comparing to free fall. You wouldn't have that speed, because I mean, think about it. Just like think about it. Like you're like literally invest all your attention and focus and energy into that one subject, and inshallah in the end you're gonna crack it, okay? But if you have like, I'm not saying you cannot do it, but I'm just saying it takes more effort. So don't worry about that. You have 2 classes for khulidum, okay? You have to invest, like obviously it's gonna be less, okay? So it's just gonna be less, all right? Anyways, I don't even want to say anything more, but that's just it. It will reach faster, reach the bottom in less time, reach the ground faster, and the reason is for that is because in free fall the gravitational potential energy is purely converted just to translational kinetic energy, whereas in inclined it's not. That's it. Bye.